to introduce to you how to solve problems
about the chances and probabilities using
binomial distribution.
Here is our situation.
In order to find out that the problem or the situation needs a binomial probability distribution as a solution, first, it must possess the following properties.
1. The experiment consists of numbers of repeated trials.
In the problem, the selection of one baby 5 times by the priest is the number of repeated trials.
2. Each trial results in two possible outcomes that may be classified as a success or a failure.
Because the problem asks for the probability that 2 out of 5 babies selected are from November, the possible outcome for each selection may be classified as success, which is baptized on November, or as a failure, which is either baptized on October or December. 3. The probability of a success, denoted by P, remains the same from trial to trial. The way the priest selects 5 babies, the probability of success remains the same in every selection. 4. Each trial is independent of the previous trial. Lastly, every selection by the priest does not affect the probability of the next selection. Thus, each are independent from one another.
The formula for finding the probability of a binomial distribution is denoted by
probability of x equals to the quantity of n NCRx times p to the power of x times q to the power of n minus x, wherein
n is the number of binomial trials.
X is the number of successes among number of trials.
P is the probability of success in one of the number of trials.
Q is the probability of failure in one of the number of trials. If this variable is not given, simply subtract 1 from P.
In order to find P and Q, we must sum up all the population of the babies because the total population is the basis to find the probability of both P and Q. Thus, we get the sum of 250. Classify first the values of success from failure. Then divide both values from the total population. We can get P and Q. The number of trials in the problem is the number of times the priest selects, while the value asked in the problem is the number of successes among trials. So n is 5 and x is 2. After finding out the values, you can now substitute it to its corresponding variables. N is to 5, x is to 2, p is equal to 49 over 250, and lastly, q is equal to 201 over 250. In these series of operations, first, we have to find the answer of 5, choose 2. Now we get 10. Before we get to the q, we have to finish the operation in its exponent, hence we get 3. Then, we solve for p. 49 over 250 raised to the power of 2. Now we get 0.38416 millionths. Now, let's continue to q. 201 over 250 raised to the power of 3, we have 0.519,718,464 billionths. Multiply both p and q, we've got an answer of 1,996,550,451,100 billionths. Lastly, multiply the product of p and q to the 10. Now, we have the final answer. 1,996,550,451 10 billionths. Therefore, the probability of having 2 out of 5 selected babies that are baptized in November is 0.1,996,550,451 10 billionths, or 19.97%.